Yes, today we are going to start chapter number 13, time and motion. Time and motion. First we can do that is the knowledge of time is essential for carrying out our daily activities. For example, why you all of us take the breakfast in the morning, lunch in the afternoon and dinner in the evening or night time. So how we can take? We can take these at different time because of knowledge of time. We are having the knowledge of time. That's why we are doing our daily activities according to our time. So knowledge of time is essential for carrying out our daily activities. So that is two devices nowadays we are mainly using is the clock and the watches. Clock and the watches. Then next is measurement of time in ancient time. How people can measure the time in the ancient time. So ancient time they are taking they are doing like this, that is one sunrise to the next sunrise they will call that they will called as a day or a solar day. One new moon to the next new moon is called the month, and the earth to complete one revolution of sun is called the 1 year. Is called the 1 year. So in the ancient time also they will do the calculation like this. One sunrise to the next sunrise was the day, one next moon to the next new moon was the month, and the earth to complete one revolution of the sun was 1 year. So measurement of time is essential. All of us know very well, that is in your school also, each and every period is according to the time. So measurement of time is essential. All the clock and watches we use based on the principle of periodic motion. On what principle it is based? All clocks and watches based on which principle? That is periodic motion. What do you mean by periodic motion? Means repeating itself at a regular interval of time. Means clock repeat itself at a regular interval of time. Means the motion which repeats itself at a regular interval of time is called periodic motion. All clocks and watches work on the principle of periodic motion. So before starting this, one instrument used in this is simple pendulum. We can do this now. What do you mean by simple pendulum? Yes, next topic is simple pendulum. Simple pendulum. What do you mean by simple pendulum? Simple pendulum consists of a small metal ball. It is a small metal ball suspended by a long thread. Means it is suspended by a long thread from a rigid support such that the bob is free to swing back and forth. Free to swing back and forth. I have made this. See, if I will tie it with some rigid, if it is a small metal ball and suspended by a long thread, this is suspended by a long thread, form is rigid support. Form here I will tie with some stands. Stands are in the science lab. Suspended. Then when it will move to and forth motion like this. Clear? Who gave this concept? That is Galileo. Who gave this concept? Simple pendulum? Galileo. So the definitions covered in this simple pendulum. First is the length of the pendulum. What do you mean by the length of the pendulum? Length of the length of the pendulum means the length of the thread. Means length of the thread. This is how we can measure, that is length of the thread. Length of the thread means to say that is length of the thread from the point of suspension to the center of the bob. To the center of the suspended, from the point of suspended to the center of the bob. Next definition is the mean position. When there will be mean position, it means that the object is at rest. If it is will be like hang like this, it is in the rest position, then it will be in the mean position. Next is extreme position. What do you mean by extreme position? The position where the bob is at the maximum distance from the from the maximum, that is it is in the mean position, that is it is in the rest position. When it will go like this, maximum it will move, then it is called the extreme position. Then oscillation. One complete to and fro motion of the bob about its mean position. Means this is the rest position. One this side, then this side, then again at its mean position at rest, like this. See. First it will go toward left, then right, then at the center. Then it is called the oscillation. Oscillation means to say one complete to and fro motion of the bob about its mean position. Mean position means to say at rest. Clear? The next definition which is going to covered in this is, so next is amplitude. Next is amplitude. What do you mean by amplitude of the pendulum? As we know, the maximum displacement of the bob from its mean position to either side. Mean position to either side means to say while hanging, both the side it will move. From left, first left to right, then again left to right, then in the center. Mean position, this is the amplitude. Means maximum displacement. Means like this, how much maximum displacement the bob has taken. Both the sides, left and right side. Next is time period. How much time bob has taken? Means the time taken by the bob of a pendulum to complete one oscillation. One oscillation means to say to and fro motion. Next is frequency. The number of oscillation made by a pendulum in 1 second. Means we can take a stopwatch in our hand and count the maximum number of oscillation made by the bob in 1 second. That is called its frequency. How we can calculate the frequency? Means 1 upon time period. With this we can count the frequency of the bob in our science lab. Yes. On which principle simple pendulum is based? That is, it is based on, that is, principle of simple pendulum is where it is used. It is used in the pendulum clock, and it is based on the principle of oscillation. Means simple pendulum where it is used in the pendulum clock, and it is based on the principle of oscillation of pendulum. And oscillation of pendulum controls the movement of hands of the clock. It will control the movements of the hand of the clock. And for measuring, we use stopwatch. Where we will use stopwatch? For measuring shorter intervals of time. Where we can measure only short intervals of time, we will use a stopwatch. And for accuracy of time, which type of watches we can use? We can use the atomic clocks. Nowadays, atomic clocks are used everywhere for the accurate measurement of time. Next is unit of time. What do you mean by the unit of time? The standard unit of measuring time is second. All of us know very well. Standard unit for measuring time is second. Second in short form we will write small s, small letter s. So 60 seconds makes 1 minute. 60 minutes make 1 hour. We can donate with MIN. In small hours, small h. 24 hours form 1 day. 30 days make 1 month. Clear? Means 60 seconds makes 1 minute. 60 minutes makes 1 hour. 24 hours make 1 day. 30 days make 1 month. 12 months makes 1 year. 10 years is the 1 decade. And 100 years 1 century, like in cricket. 100 runs from 1 century of the person, and 1000 years is the 1 millennium. So unit of time is second. Measuring time we can use is the second. Clear? Next topic is covered in this chapter is motion. Before starting motion, first of all we can do the definition of rest. What do you mean by rest? What do you mean by rest? You are seeing in your, while sitting in your home, you can see so many things are lying in your home. That is, all these are in resting position. So rest, when it does not change its position with time or with respect to its surrounding, does not change its position is fixed, then the object is said to be at rest. And what do you mean by motion? Both these are related with each other. So what do you mean by motion? When an object changes its position with time or with respect to its surrounding. For example, I am changing my position, means I am moving from here to there. With respect to time, I will take some time to cover some distance. Then when I will move from one place to another, take some time, then I am in position. If I am standing still here, then I am in the resting position. Clear? Both the definition. So in 6th class you have done so many types of motion: rectilinear, circular, rotational and periodic motion. So according to it, there is some motions are slow and some are fast. So what do you mean by slow and fast motion? When an object which takes longer time to cover a certain distance. Obviously this type of motion is called the slow motion. Means when an object takes longer time to cover a certain distance is said to be a slow motion. When an object takes shorter time to cover a certain distance, then it is called the fast motion. You can take the example from the road. When there is rush on the road, then vehicle cover a shorter vehicle move slowly because it takes longer time to cover a small certain distance. Whereas when the road is empty, then vehicle move fast, cover shorter time to cover a certain distance. According to it, that is, we can identify slow and fast motion. So what do you mean by motion? When an object changes its position with time or with respect to its surrounding, then it is said to be a motion. Motion in this is, we can go with slow and fast motion. Next topic we are going to cover is the speed. So next is, what do you mean by speed? Speed of a moving object. What do you mean by speed? Always speed is of the moving object. Speed of a moving object is the distance travelled by it in a unit time. Means if any object is moving, it will cover some distance. While covering some distance, it will take some time to cover that distance. So this is called the speed. Speed of a moving object is the distance travelled by it in a unit time. How much time it will travel some distance. So according to definition, its formula is distance travelled upon time taken. Distance travelled upon time taken. For example, a car travels distance of 240 kilometers in 4 hours. A car travels distance of 240 kilometers in 4 hours. Then its speed will be in kilometers per hour. Is distance, we can write the formula, that is Distance is equal to 240 kilometers and time taken to cover that 240 kilometer is 4 hours. So we can write down 4 in place of time. So it will, the answer is 60 kilometers per hour. Means speed of the car is 60 kilometers per hour. Means 1 hour it will cover 60 kilometers in a hour. Clear? Next is unit of speed. Unit of speed. We know that distance we can measure, distance travel we can cover in, right, in meters and time is in second. Clear? So distance is in meter and time in second. According to this, it will standard unit is meters per second. Meters per second. Meters per second. This is per. Oh, clear? So next is speed of vehicle in kilometer per hour. When the vehicle cover a longer distance, we can write kilometer per hour. Shorter distance covered in meters per second. So speed of vehicle in kilometer per hour is measured with the help of speedometer. All of you know where the speedometer is fixed. It is fixed on the handle of the vehicle, or in car it is in the steering. Where the steering is there, near down there, that is we can note the speed of the car, vehicle. And next, distance traveled in kilometers per hour, kilometers. So distance traveled in kilometer is we can know with the help of odometer. Both these meters are fitted in the vehicle's handle. All of us know very well this thing. So first numerical problem is the speed of a moving car is 72 kilometers per hour. Means here the speed is given. We can convert the speed into meters per second. So you know that 1 kilometer is equal to 1000 meter. You know that thing very well. 1 kilometer is equal to 1000 meter. Whereas 1 hour is equal to 60 seconds into 60 minutes. So it will be 3600 seconds. When we will write speed is equal to 72 into 1000 meters upon 1 into 3600 seconds, then it will be 20 meters per second. The answer will be 20 minutes per second. Rest of the numerical examples in your book is you can write down the given units and put it in the formula, and then you will solve that. These are rest are same. Okay. Next topic we are going to cover is uniform and non-uniform motion. What do you mean by uniform and non-uniform motion? Next is uniform and non-uniform motion. What do you mean by uniform and non-uniform motion? Means when object cover equal distance in equal interval of time, then it is said to be then it is said its speed remains constant. Speed remains constant. That we call that is uniform motion. What do you mean by uniform motion? When it covers equal distance in equal intervals of time, then its speed should be constant. So it is having uniform motion. So non-uniform motion, from the name clear, when it covers unequal distance, in equal interval of time, but its speed should not be constant, it should be varying. Means when a vehicle or car is moving on a busy road, then its speed is varying. Sometimes it will slow down, sometimes it will go high. Then it is called a non-uniform motion. On a busy road, motion is always non-uniform. But in a uniform motion is when there is no busy road. Next, according to it, how we can plot a graph of both uniform and non-uniform motion. So what is graph? Graph will show how distance travelled by a moving object. Graph is a graphical representation. It will show that how distance travelled by a moving object with change its while changing its time. So now we are going to draw the graph of uniform motion and non-uniform motion, how it varies with the time. So there in this we can cover two, how we can plot the graph while taking the two variables. First is independent and second is dependent. What do you mean by independent variable? What do you mean by independent variable? Independent variable means to say the quantity which is made to be vary with our will. Means quantity which is made to be vary with our will. Next is dependent, the other which varies as a result of this change. Means it will vary as a result of this. The other which varies as a result of this is called the dependent variable. In this case, the time is independent. In this case, time is independent. Time is independent, and while plotting a graph, we can take the time on x-axis. While next is time unit is unit of time is the minute and the clear, whereas the dependent variable, the other which varies as a result of this change is called the dependent variable. This is we can take on the y axis. Now after this we can I will show you how you can draw the graph. Yes, with the help of distance time graph, we can know the uniform, non-uniform motion of the object, or object is at resting position. We can identify with the help of a distance time graph. This I have drawn the distance time graph. You can take a graph book, draw the line. You know this is the x-axis and this one is the y-axis. I have told you the two variable quantities, independent quantity, that is time, you should take on the x-axis, and dependent means distance dependent on the time, you should take on the y-axis. Clear? I am giving this margin 1 in 1. Here you will write time. We can measure in minutes, and distance. Distance we can measure in kilometers, and then you can give the margin, that is in 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, how much distance it is covered in 1 minute. So 1, 2, 3, 4, or you can write 2, 4, 6, 8, 2 kilometer, 4 kilometer, 6 kilometer, 8 kilometer, like this. Okay, now I am showing you the graph how uniform motion is, we can draw how uniform motion of the distance time graph. In uniform motion, what do you mean by uniform motion? That when an object covers equal distance in equal interval of time, then equal distance in equal interval of time, 1 minute, 1 kilometer, 2 minutes, 2 kilometer. Then the graph will be in uniform motion. Then it will show the straight line. When the motion is in uniform, then the graph will, when we will plot the graph, it will give us a straight line. If the object is moving in non-uniform motion, then the line should be curved. Means, what do you mean by non-uniform motion? When an object covers unequal distance in equal interval of time, then we can call it, where we said that it is a non-uniform motion. Obviously, 1 minute, speed is going to be increase and decrease. Then there will be a curved line showing that means motion is non-uniform motion, not constant speed. Here it is showing that speed is constant. It shows that speed is not constant, it is varying with the time. Okay. Then next, when object is at rest, then the line is a horizontal line. Means object is at resting position, then the line is in horizontal. This straight line shows that the object is at the resting position, line is straight, horizontal. Okay, then means when it is in the center straight, the object is in uniform uniform motion. When it is in curved line, then object is in non-uniform motion. When it is straight horizontal line, then object is at resting position. With the distance time graph, we can know what type of motion the object is having. Means it is having constant speed, where the speed is varying and it is at the object is at resting position.